Today we begin reviewing what we learned about rational numbers in that chapter with fractions and decimals and adding fractions and dividing fractions and subtracting fractions. All of that fraction work and the rational numbers and the decimals, that's what we're reviewing today. So we're going to start out with a quick review of the vocab. Again, you should have all of this in your notes. A repeating decimal is a decimal whose digits repeat in groups of one or more, so a pattern or not. Bar notation is what we use to represent repeating decimals. So in this example here, the pattern is 0.61, 61, 61, that's what repeats. So we can just put a bar over the 61 to indicate that that's the pattern that repeats. And terminating decimals are decimals whose digits come to a complete stop. So when asked to write a fraction as a decimal, we know that the bar represents division. So in order to write this as a decimal, we're going to need to divide the numerator by the denominator. And in order to do this, I know that 20 cannot go into 7. So I'm going to extend this bar here and put a decimal. Once I've placed a decimal, I can add my 0 here. I know again 20 goes into 7 0 times, but 20 goes into 70 3 whole times. 3 times 20 is 60. I subtract, I get 10. And I can drop down a 0. Now, how do I know that I can drop down a 0? Well, after the decimal point, there is an infinite number of zeros. I may not need to use all of them. In this case, I'm actually only going to need to use the next 0 only, so I won't need these 3. Once I've solved the problem or the decimal has terminated, I don't need any of those extra zeros. So, I know 20 goes into 100 5 whole times. 5 times 20 is 100. I subtract. Once I get this 0 right here, I know I'm done. So I know that my final answer is that 7/20 equals to 0.35. So that's the process for changing a fraction to a decimal. Okay. Sometimes you'll be asked to write a mixed number as a decimal. In this particular case, the fraction 3/4 is one that's very common. We should have it memorized that 3/4 is actually 0.75. But in order to show this work here, there are two ways of going about it. I know that 5 is my whole number, so I know my answer is going to be 5 point something. So in this case, the first way that I can go about this is I can go, okay, well my fraction is 3/4, so that's 3 divided by 4. 4 goes into 3 0 times, so put down a decimal. 4 goes into 30 7 times, that's 28. Subtract, I get 2, drop down one of those zeros. 4 goes into 20 5 times. So then I get that 3 divided by 4 is 0.75. So my answer is 5.75. That's one way to go about doing it. The other way is to circle method and get an improper fraction. Well, I know that 5 3/4 is going to be equal to 23/4. So then I can go, well, that's 23 divided by 4. 4 goes into 2 0 times, but it goes into 23 5 times. That's going to be 20. Bring down the 3. Okay, so 4 does not go into 3, so put down a decimal. Drop down a 0. 4 goes into 30 7 times. And we go through the same process again, only this time we know that the 5 being the whole number is included within our work. So 5 times 4 is 20. Subtract, I get 0. So my answer, once again, is 5.75. So two ways to go about doing this. Alright, sometimes your decimals will work out in a fashion where they repeat. So I know 7 divided by 9 is what I'm trying to figure out here. So I'm going to put up my decimal right away because I know that 9 cannot go into 7. Alright, so 9 goes into 70 7 times. That's 63. I subtract, and I get 7. Well, again, 9 goes into 70 7 times. I get 63. I subtract, I get 7. So I notice that I'm going to get a repeating pattern. So 7/9 we can say is equal to 0.7 repeating. Now, if you're given a decimal and asked to turn it into a fraction, like in this particular case, you're going to need to remember your place value. So find the fraction of fish in the aquarium that are goldfish and write your answer in simplest form. Well, I know that goldfish are equal to 0.15. So whenever you want to write a decimal as a fraction, you need to think about your place value. I know that this one is the 10th place. This is the tenths. And I know that this here is the 100th. So that means anything that's in that first decimal place is going to be over 10. Anything that's in that second decimal place is going to be over 100. If I were to keep going, it would go out to 1,000, then 10,000, and so on and so forth. But in this case, I stop at hundreds. So this is actually going to be equal to 15 out of 100. And since it asks me to put this in simplest form, I'm going to reduce by 5, both in the numerator and the denominator. That's going to give me 3/20. So that means that 3/20 of these fish are goldfish. Now, moving on, sometimes you'll be asked to compare rational numbers or put them in order. And in order to do that, well, what's the difference between 0.25 and 3/4? Which one's larger? Well, in order to do that, I can think of 3/4 and 0.25 as being two decimals, while 3/4 is 0.75, which is much larger than 0.25. A quick review, again, you do have this in your notes from this chapter. Just a rational number, a reminder, is a number that can be expressed as a ratio of two integers, so a fraction in other words. Or a rational number could be a terminating decimal or a repeating decimal, or even an integer. Okay, so we move on. All right, sometimes whenever we're comparing fractions, we're going to need what's called a common denominator. And a common denominator is a common multiple of the denominator or two or more fractions. And when we're adding and subtracting, well, this will be later, you're going to need a least common denominator so that you get the simplest denominator that you can work with in your problem. The least common denominator is the LCM, or the least common multiple between the two denominators. So if I look at the fractions 3/8 and 5/6, okay, and I want to compare them, the first thing I'm going to need to do is find the least common denominator. Well, you might look at those and say, well, 3/8 versus 5/6. I could multiply both of these denominators by each other to get 48. But there's a smaller number that 8 and 6 both go into, that is the least common multiple of these two numbers. And that is 24. So I could actually multiply this one by 3 and this one by 4, giving me, and I'm going to write straight down, okay, that's going to be 9/24 for the first fraction, and that's going to be 20/24 for the second fraction. So the LCD of these two fractions is 24, and I know the fraction that is bigger is actually the 5/6, and I know that because 9 is less than 20. So, when asked to figure out if fractions are greater or larger, you need to first bring them to a common denominator. In this case, they are at a common denominator. And in this particular problem, the mixed number that is going to be larger is -3 and 3/8. And I know this because these are negative numbers, so whenever numbers are negative, the number that is less negative is always going to be bigger. So in the case of 3/4 and 4/5, I'm not quite sure till I bring them to a common denominator. Well, 3/4 and 4/5, their common denominator is going to be 20 times 5 times 5 times 4 times 4. So that's 15/20 versus 16/20. So I know that 4/5 is greater. In this particular case, Mr. Huang's class of 20 students, Mr. Huang's class, 20% of his students own roller shoes, and in Mrs. Trevino's class, 5 out of 29 students own roller shoes. Which class does a greater fraction of students own roller shoes? Well, now I'm comparing 20% to 5/29. So in this case, I might think to myself, okay, I could do 20 out of 100 for the percent versus 5 out of 29, but 20 out of 100 and 5 out of 29, or 1/5, that's going to be a little, I could get a common denominator for that, but let's see, can I turn these both into decimals? I know that 20% is 0.2. Oop, that's 0.2. I took my decimal and I moved it twice over, or I went 20 divided by 100 to get 0.2. I know that 5/29 is simply going to be 5 divided by 29. Okay, so in this case, 5 divided by 29, let's see. I know 29 cannot go into 5, so let's put a decimal. I know that 29 can go into 50 one time as a whole. So I actually can stop there. I'm going to subtract, borrow 4, 10. 10 minus 9 is 1. That's going to be 4 minus 2 is 2. So I can actually stop there because I know 5/29 is going to be smaller than 0.2. So in Mr. Huang's class, there's a greater fraction of students who own roller shoes. Okay, so when we're adding and subtracting fractions with common denominators, it's pretty simple. All right, we are going to consider fractions that have common denominators to be called like fractions. Okay. To add or subtract like fractions, we simply just add the numerators and leave the denominator the same. So in the example of 5/10 plus 2/10, I just add the 5 and the 2, which gives me 7/10, and I don't need to reduce that. Same with subtraction, I just subtract the numerators and leave the denominator alone. So in the example of 5/9 plus 2/9, that's going to be 5 plus 2 over 9. That's going to give me 7/9. I can't reduce that, so it's already in simplest form. Review of our sign rules. Negative 4/6 plus negative 1/6. Well, that's going to be negative 4 plus negative 1 over 6. Since these are both negative, I know my answer is going to be negative 5 over 6. So here's a subtraction problem. So we're going to keep change. I'm going to get negative 5/8 plus negative 3/8. So that's going to be a denominator of 8. Negative 5 plus negative 3, that's going to be negative 8 over 8. This one is not in simplest form. Negative 8 over 8 is actually going to equal to negative 1 as my final answer because 8 divided by 8 is 1. Alright, so now what if we want to add or subtract fractions that are unlike, meaning they have different denominators? Well, to add or subtract fractions with different denominators, you need to rewrite or rename the fractions using a least common denominator. Then you add or subtract, and then you simplify. Alright, so you can add and subtract unlike fractions, but you need to bring them to a common denominator. So if I'm looking at 3/4 and 1/5, well, I know that 3/4, so I'm just going to widen the problem a little, plus 1/5. Well, I need to bring these to a common denominator. I know 3/4 and 1/5 are going to have a common denominator of 20. So I'm going to multiply by 5, multiply by 4. My new fractions will become 12/20 plus 4/20. So that's actually going to be 16/20, which reduces by 4 in the numerator and the denominator to 4/5. And that's my final answer. Sometimes the problems will be a little more complex. So since in this case we have order of operations, we know we need to do what's in the parentheses first. I'm looking at my 4 and my 9, so my common denominator is going to be 36, so I'm actually going to change all of my fractions. So the first fraction I'm going to multiply by 9 over 9, so that's going to give me negative 27 out of 36. I'm going to multiply the next fraction by 4, so that's going to give me 20 out of 36. The last fraction I'm going to multiply by 9 plus 63 over 36. So when I go to add, negative 27 plus 20, that's going to be negative 7 over 36. So that's the parentheses that are done now, plus 63 over 36. Well, negative 7 plus 63 is actually going to be 63 minus 7, which is going to be 50. I hope you're solving it in my pause. So 63 minus 7, all right, 56 out of 36. So then we need to reduce that. I know 36 can go into 56 one whole time, leaving me 36, which we can reduce by 4 in the numerator and denominator, which is 1 and 5/9. Okay, let's keep moving. Negative 2/3 minus 1/2. Common denominator of 6, that's going to be negative 2 over 3 multiplied by 2 over 2 in case we forgot how to do that, minus 1/2 multiplied by 3 over 3. So that's going to be negative 4/6 minus 3/6. So I'm going to keep change. That's going to become negative 4 plus negative 3 all over 6. So that's going to equal negative 7 all over 6, which is equal to negative 1 and 1/6. Okay, so sometimes we're going to be adding and subtracting mixed numbers. So when the case is that we're adding and subtracting mixed numbers, same rules apply. Common denominators I can work with easily. Non-common denominators I need to change to common denominators. So in this case, the first thing I'm going to do is I'm going to add my whole numbers. 7 plus 10 is 17. And then 4/9 and 2/9, well, that's going to be 6/9, which actually reduces to 2/3. So my answer is 17 and 2/3. Okay? In this case, I don't have common denominators, but they're easy to find. So I'm going to have 8 and 5/6. Common denominator of 6 minus 2 and 2/6. So I know that 8 minus 2 is 6. 5 minus 2 is 3. That's going to reduce to 6.5. Now in the first example, I wrote everything out. I broke it down, 8 minus 2, and then I did 5, 6, minus 2, 6. But as you gradually get to be more proficient at this, I would like you to be able to, work on it all at the same piece. All right, so in this one we don't have common denominators, but again, they're easily found. 9 and 7/10 minus 4 and 6/10. So 9 minus 4 is 5. 7 minus 6 is 1. My final answer is 5 and 1/10. All right, here's a case where I'm going to have to borrow. So I know I have 8 and 1/5 minus 3 and 3/5. And here's why I don't want you to jump to just going, oh, okay, that's going to be 8 minus 3, and that's 1/5 minus 3/5. Because in this case, and I'm actually going to erase that, in this case, I can borrow. So this is an instance where we're looking at something like 111 minus 92. And I know that I'm not going to do 1 minus 2 is negative 1, and 1 minus 9 is negative 8, and 1 minus nothing is 1. No, I'm not going to do that because I can borrow. So I could technically borrow from the 1 to make I could borrow 10 from here, and from the 10th place, making this an 11. 11 minus 2, and then I'd go on from there. So just like we could do with whole numbers, we can with fractions. So if I have 8 and 1/5 minus 3 and 3/5, let me rewrite that. Okay, I can actually borrow 1 from the 8. But when I add the 1 to the 1/5, I'm not just adding 1 over 1, I'm adding 5 out of 5, which is equal to 1. So the reason that I know it should be 5 out of 5 is because I want 1, but I want it in the form of a common denominator of 5, so I'm actually going to make that to be 5 out of 5. So then this is going to become 7 and 6/5 minus 3 and 3/5. So now I can go ahead and start solving. 7 minus 3 is 4, 6 minus 3 is 3. My final answer is 4 and 3/5. Okay, so I'm actually going to stop here and do another video on reviewing multiplying fractions and mixed numbers and dividing fractions and mixed numbers. So if your only review piece was with the addition and subtraction and you were golden with the multiplication and division, then you may only need to watch this first video. All right, I will see you tomorrow.